The Javadi Hills, a range of modest elevation in northern Tamil Nadu, offer a tranquil escape into a landscape of rolling hills and verdant valleys. Geologically part of the Eastern Ghats, they rise from the surrounding plains, creating a varied terrain. The name, Javadi, or Jawari, likely comes from local linguistic traditions, though its precise meaning is uncertain. Historically, the region has been home to diverse communities, including groups connected to the Iron Age cultures of the peninsula. While the Irregular are often mentioned, the tribal history is complex, and further research is needed to fully understand the various groups that have inhabited these hills. It's important to note that communities in the neighboring Yelagiri Hills, sometimes referred to as Malayali, are a distinct tribal group with their own traditions and language, separate from the Malayalam-speaking people of Kerala. These Yelagiri, Malayali, likely have historical connections to broader cultural and linguistic patterns of the region, but their specific origins and history require further investigation. Village names like Jamnamuthur, Alangayam, and Kavalur are valuable clues to the region's past. The Javadi Hills are a haven for diverse flora and fauna. At higher elevations, shola forests, with their characteristic stunted trees, dense undergrowth, and interspersed grasslands, create a unique ecosystem. Deciduous forests, more common at lower altitudes, paint the hillsides in varying shades. Numerous streams and rivers, tributaries of larger rivers like the Palar, drain the hills. Birdlife is abundant, and you might spot the greater racket-tailed drongo. Monkeys, most likely bonnet macaques, are a common sight. The Javadi Hills offer a peaceful retreat, a chance to appreciate the natural beauty of the Eastern Ghats and to reflect on the rich, if not fully understood, history of the region and its people. M.K. Vainu Bappu, 1927–1982, was an Indian astronomer, often hailed as the father of modern Indian astronomy. Born in Kodiyalam, near Kumbakonam, Tamil Nadu, he displayed a keen interest in astronomy from a young age, nurtured by his father, also an astronomer. Bappu pursued his studies at Harvard University, where he earned a Ph.D. in astronomy. His significant contributions to the field include the discovery of the Wilson-Bappu effect, which links a star's spectral features to its luminosity. He was instrumental in establishing several astronomical institutions in India, most notably the Vainu Bappu Observatory in Kavalur, named in his honor. Bappu also served as president of the International Astronomical Union, further cementing his legacy as a pivotal figure in the development of astronomy in India. The Wilson-Bappu effect, first described in 1957 by Olin C. Wilson and M.K. Vainu Bappu, reveals a relationship between a star's luminosity and the width of its calcium-2, that is, calcium-2 H and K emission lines. These prominent spectral lines, formed in a star's chromosphere, exhibit broadening due to Doppler shifts caused by turbulent motions. The effect demonstrates that more luminous stars, typically cool giants and supergiants, possess more extensive and turbulent chromospheres, resulting in broader emission lines. This empirical relationship offers a valuable tool for estimating the absolute magnitudes of such stars, a crucial step in determining their distances and understanding galactic structure. While not without limitations and superseded by more precise modern techniques, the Wilson-Bappu effect remains a historically significant contribution to stellar astronomy. On the 2nd of July 1949, when Bappu was taking pictures of the night sky, he spotted a bright moving object which he had rightfully understood to be a comet. When he turned to his professor, Bart Bach, and colleague Gordon Newkirk, they confirmed the discovery. They calculated the orbit of the comet, which revealed that the comet would reappear only after 60,000 years. The International Astronomical Union officially named the comet as the Bappu-Bok-Newkirk comet, C/1949 N1. Bappu also received the Donohoe Comet Medal of the Astronomical Society of the Pacific. The Vainu Bappu Observatory of the Indian Institute of Astrophysics traces its origin back to 1786 when William Petrie set up his private observatory at his garden house at Egmore, Madras, which eventually came to be known as the Madras Observatory. Later it was moved to Kodaikanal and functioned there as the Kodaikanal Observatory since 1899. However, Kodaikanal had very few nights available for observation, and hence astronomers searched for a new site after India's independence. M.K. Vainu Bappu, who took over as the director of the Kodaikanal Observatory in 1960, found a sleepy little hamlet called Kavalur in the Javadi Hills as a suitable site for establishing optical telescopes for observing celestial objects. This came to be known as Kavalur Observatory. Observations began in 1968 with a 38 cm telescope made in the backyard of the Kodaikanal Observatory. Kavalur Observatory is located in Kavalur in the Javadi Hills in Alangayam. The Kavalur Observatory is located in a 40-hectare forest land in Tamil Nadu. The observatory is at an altitude of 725 meters above mean sea level of longitude 78 degrees 49.6 E, latitude 12 degrees 34.6 feet N. Apart from being reasonably away from city lights and industrial areas, the location has been chosen in order to be closer to the Earth's equator for covering both northern and southern hemispheres with equal ease. In addition, its longitudinal position is such that it is the only major astronomical facility between Australia and South Africa for observing the southern objects. The first telescope was of 38 cm aperture, with which astronomical observations were started in 1968 at Kavalur Observatory. The 75 cm telescope has been completely designed and fabricated at the workshops of the Indian Institute of Astrophysics. In 1972, a 1-meter telescope made by Carl Zeiss Jena was installed at Kavalur. Vainu Bappu started the 2.3 meters aperture telescope, designed and built within the country. Bappu died in 1982 and would not see the completion of the telescope. On 6 January 1986, the observatory was renamed as Vainu Bappu Observatory and the 2.3 meters telescope as Vainu Bappu Telescope. Deep sky observations are carried out with this telescope using a variety of focal plane instruments. The equatorially mounted horseshoe yoke structure of the telescope is ideally suited for low latitudes and permits easy observation near the North Celestial Pole. The telescope has a f3.25 paraboloid primary of 2.3 meters diameter with the prime focus image scale of 27 arcsec per millimeter and a Cassegrain focus image scale of 6.7 arcsec per millimeter. This telescope has been operated as a national facility and attracts proposals from all over the country and sometimes from outside India. The Carl Zeiss, in the context of the 40-inch telescope at the Vainu Bappu Observatory, VBO in Kavalur, refers to the same Carl Zeiss who founded the renowned optical company, Carl Zeiss AG. The 40-inch telescope at VBO was manufactured by Carl Zeiss AG, a company known for its high-quality optical instruments. Carl Zeiss AG, founded by Carl Zeiss in 1846, has been a leading manufacturer of optical systems and optoelectronics. The company's expertise in producing precision optical instruments made it a suitable choice for the construction of the 40-inch telescope at VBO. The DIMM, Differential Image Motion Monitor, telescope at the Vainu Bappu Observatory, VBO, in Kavalur, India, is a specialized instrument used to measure atmospheric turbulence. While it's not designed for direct astronomical observation like the larger telescopes at VBO, its specifications are crucial for understanding the conditions under which those observations are made. Unfortunately, precise technical specifications for the VBO's DIMM telescope are not readily available in the public domain. However, based on general information about DIMM telescopes and the research conducted at VBO, we can infer some key aspects. The primary function of the DIMM telescope is to assess the quality of the astronomical, seeing how much the Earth's atmosphere blurs images. This is done by measuring the differential motion of the images of two stars. DIMM telescopes are typically small, often with apertures of a few centimeters. They are designed to be portable and robust, capable of operating in various weather conditions. The core of a DIMM telescope is a high-speed camera and sophisticated software that can precisely measure the tiny differences in the positions of the two star images. This data is then used to calculate parameters like the Fried parameter, a measure of seeing quality, and the coherence time, how long the atmosphere remains stable. The DIMM telescope at VBO is likely located on the observatory grounds in a position that provides a representative view of the sky conditions. Why is the DIMM telescope important? Understanding atmospheric turbulence is essential for optimizing astronomical observations. The data from the DIMM telescope helps astronomers at VBO to schedule observations. Knowing the seeing conditions allows astronomers to schedule observations for times when the atmosphere is most stable, maximizing the quality of their data. Optimize telescope settings. The turbulence data can inform adjustments to the larger telescopes, such as the use of adaptive optics systems to compensate for atmospheric blurring. Site characterization. Long-term monitoring of atmospheric turbulence helps to characterize the overall quality of the VBO site for astronomical observations. While the exact specifications of the DIMM telescope at VBO may not be publicly available, its role in supporting the observatory's research is undeniable. It's a vital tool for ensuring that the VBO's larger telescopes can capture the best possible images of the cosmos. DIMM, Differential Image Motion Monitor telescopes, are used to measure the quality of astronomical seeing by monitoring the motion of star images. Here are some notable DIMM telescopes around the world. Devasthal Optical Telescope, in Nainital, India. 3.6-meter telescope is the largest in India for studying celestial objects at optical wavelengths. It uses a DIMM for site characterization. Indian Astronomical Observatory, IAO, in Hanal, Ladakh, India. Observatory hosts a 2-meter optical infrared telescope and a robotic DIMM seeing monitor. Paranal Observatory in Chile, home to the Very Large Telescope, VLT, observatory uses DIMM telescopes for site monitoring. Mauna Kea Observatories in Hawaii, USA. Several telescopes here, including the Keck Observatory, use DIMM for site characterization. La Silla Observatory in Chile, observatory also employs DIMM telescopes for monitoring atmospheric conditions. DIMM is a technique rather than a telescope type. Collected info need double checking. The DIMM in VBO Kavalur is a recent addition to VBO Kavalur. The 2009-10 academic report of Indian Institute of Astrophysics has a photo of DIMM of VBO in its early form.
moving toward east side. So this is right ascension movement.
Whatever image you take, everything is displayed and stored in the computer. A few decades back, they used to take photographs or just to sit at the top of the telescope to get the photograph, and they use photographic plates.
Star, the whole sun, few kilometers long, like 20 to 30 kilometers size, whole sun, that is the density of the neutron particle. If the neutron star size is 3 to 5 times massive than our sun, we need 10 to 15 times solar mass explode. The core will collapse extremely because of extreme gravity. So, your QR codes for our social media handle, we are putting updates.
The observatory is home to the Vainu Bappu Telescope, the largest telescope in Asia until a 3.6-meter telescope was set up at Devasthal, Nainital, by Aries. ARIES stands for Aryabhata Research Institute of Observational Sciences. It is an astronomical observatory in Nainital, India. It has a diameter of 2.3 meters and was first used in 1986. Along with the Vainu Bappu telescope, the observatory has two other telescopes, a 1-meter Zeiss manufactured and another 75-centimeter Cassegrain reflector currently being refurbished. The observatory also has a Fabry-Perot interferometer. The 1-meter telescope is associated with two unique discoveries in the solar system. In 1972, atmosphere was detected around Jupiter's satellite Ganymede, and in the year 1977, participated in the observations that confirmed rings were discovered around the planet Uranus. The rings of Uranus were first discovered in 1977 by astronomers James L. Elliott, Edward W. Dunham, and Douglas J. Mink using the Kuiper Airborne Observatory. This discovery was made during an occultation event, where Uranus passed in front of a distant star, causing the star's light to dim in a pattern that revealed the presence of rings around the planet. In 1984, Kavalur reported the discovery of a thin outer ring around Saturn. On 17 February 1988, a new minor planet was discovered using the 45 cm Schmidt telescope. It has been named 4130 Ramanujan after the Indian mathematical genius Srinivasa Ramanujan. This is the first such discovery from India in the 20th century.
Just ஒரு இமேஜிங் 5 டெலஸ்கோப்